All right. Hello and greetings from McMaster University. I'm here to talk today about McMaster Engineering, in particular our Bachelor of Engineering programs. I wanted to welcome you, number one, and number two, I wanted to say that during my presentation, I'll be overviewing elements of the Bachelor of Engineering programs and on the admission aspects of it. But you're welcome to input any questions you have or any information you want in your request for information in the Q&A box below. So you'll see the Q&A box on the Zoom. Please feel free to put in questions or requests for information there. And our team will be replying to you shortly or quickly live during this presentation tonight. So welcome once again. My name is Steve Hanilovic. I'm a professor in the Department of Electrical and Computer Engineering here at McMaster University, and I happen also to be the Associate Dean Academic. And it is my pleasure to talk to you from wherever you're joining us today, from wherever in the world you're joining us. And I'm going to say good evening to those that are in our time zone here in North America. Welcome to McMaster University. Of course, it is nighttime here at McMaster, but this picture is a good example of this time of year, just in the early fall. You'll notice that McMaster University sits nestled between one of the major urban centers in Canada, meaning Hamilton, Ontario, and the nature preserve called Cootes Paradise, which borders onto Lake Ontario. And so McMaster University is in one of these fantastic locations that has the vibrancy and excitement that comes with a dense urban center, as well as the wonderful peace and beauty of a natural setting. And so it really is a lovely place to live and work. Our Faculty of Engineering and indeed the university are quite impressive, and they are impressive on many fronts in terms of rankings. McMaster University, not just this year, but several years running, is the most research intensive university in Canada. That means per faculty member, we have the most research output. Why is this important for undergraduate programs? It means that the professors that are teaching you are actively engaged in research and that are leaders in research areas in whatever discipline they have chosen. Our university is ranked among the top universities, not just in Canada, but worldwide. We are in the top 80 in the world. We have been locked in that position or better for many years. So we're firmly amongst the best educational institutions worldwide. And in fact, we're ranked #1 for global impact in Canada. And so McMaster University has some notable achievements and continues to achieve and has a long heritage and history of doing so. The symbol of McMaster Engineering, if you haven't seen it, is a fireball. That's our historical emblem. And we tend to call ourselves the Fireball family. And that's a Fireball family, a collection of students, staff, and faculty. Our programs are arranged, we have 4 main programs in engineering, and they're arranged along different disciplines. We have our engineering disciplines that are widespread, both in traditional and in emerging engineering fields. We have our biomedical engineering programs, which combine engineering core concepts with health sciences and biomedical topics. We have a computer science program, and we also have our Bachelor of Technology programs. Today, I'm going to focus on the engineering programs in this webinar, but just to make you aware, there are webinars and similar information sessions for all of the other 3 programs or program groupings that we have in the faculty. They are recorded and they are available to you. So if you'd like to go take a look at those at any time, I certainly encourage you to do so. So our Faculty of Engineering is ranked #3 in Ontario for engineering faculties. In fact, Southern Ontario has a wealth or is spoiled for choice in terms of engineering programs. There are a huge number of great engineering programs. McMaster is among the best in Ontario and worldwide. We're ranked among the top universities in Ontario and in Canada for global employability. That is no coincidence. You'll see from our paradigm or our philosophy of teaching that these are natural consequences of the way we teach our students in our undergraduate programs. Of particular pride to us and of particular importance is the statistic in the middle. Our first-year student success rate is 96.5%. This means that this is the proportion of students that make it out of level 1 into level 2 eventually. They may need supports, they may need additional time, but they are supported to get to there. Why is this statistic notable? It is among the highest retention rates, not just in Canada, but in North America. So at McMaster Engineering, when students come to our program, we're going to talk about examples of supporting our students before they even arrive in our program. And once they arrive in our level 1 program, we support them with a purpose-built, a specified group of instructors in our level 1 program, as well as advisors to support them and manage that difficult transition, often difficult transition between high school and university. So we have specialists that help do that, and the dividends of that are indeed in the fact that we're leaders in having this student retention rate. All right, so Engineering 1. This is what we call our first year. And so let's talk about, this is like the top 5 list. Some of the 5 reasons that we believe Engineering 1 is incredibly special is indeed that commitment to our students. That first year success rate of 96.5 is because of the construction of the program, because of the commitment of the faculty and the university to our first year students. One, to give them the information and the resources in order to manage their transition to university and ensure their success through our programs. We believe in co-op, we believe in experiential learning, and you'll see a lot of mention of that later on in this webinar. That I'll touch on some specific examples of that. But we believe co-op, learning by working in industry, both local, both Canadian, and international, is one of the best ways to learn engineering in practice. And we offer a co-op program, which is flexible, which fits the individual students. We recognize that there's not one way, one size fits all way to do co-op. And so we have a flexible co-op program that is paid and allows students to gain those essential industrial experiences before graduation. We have a common first year, and this common first year means that students have a common group, a common pool with instructors that are specialized to mentor students through these programs. It also allows students a transition year in order to see all of the engineering disciplines, to get a taste of all of them, understand the choices they're making, and then make a choice at the end of their first year on what their final program progression or program will be in level 2 and beyond. Once they've had that instruction, once they've had that experience in first year, that sampling of a wide range of engineering disciplines, there are over 10 degree specializations they can choose from. And so these, again, as I mentioned at the beginning, they're from the classical to more modern engineering disciplines. Students will have that choice, that ability to interact with students from those programs and instructors. So they can really make an informed decision as they transition from first year and beyond. And finally, our method of teaching is not yesterday's engineering pedagogy or yesterday's engineering approach to teaching. We have the most modern engineering educational methods, and I'm going to show you a taste of that in first year and tell you a little bit about what we do in upper years. It's based on learning by doing, learning engineering not just by watching someone do it and listening to someone tell you about it, but by actually experiencing engineering and doing it experientially. Not in second year or waiting to your fourth year, but from the minute you enter our program. From the minute you show up at McMaster University as an engineering student, you will be engaged in engineering design. Of course, the nature of the designs will grow in complexity and depth and breadth throughout your time at McMaster University, but that is a common theme in all of our programs. Design, experiential learning, learning in teams, collaborative teams, multidisciplinary teams, and doing so in a project-based context are common in all of our programs. And you do it from the minute you arrive. We don't wait to do that. We believe the best way to learn is certainly by doing. And we'll see that. I'll show you a couple examples in this short webinar tonight. And I encourage you to follow up if you have any questions. All right, so what's in our first year? So what types of courses, what kind of material will I learn in our first year? So your first year will start with, certainly with background in chemistry and in physics and mechanics, waves, electricity, and magnetic fields. These are important fundamental concepts. Engineers take the sciences as well as math. You'll see engineering mathematics is highlighted there. These are the raw materials that engineers use to solve real world problems. All right, we need to know chemistry, we need to know sciences and maths. That's very important. However, equally important are our engineering topics. How do we fuse those together to make solutions? And that is our integrated cornerstone design projects and engineering course. It is the first of its kind in the world. We are teaching with the most modern methods for engineering training. And what we're doing here is we're taking all of the engineering topics in material science, in coding, programming, in engineering design and 3D printing and manufacturing, as well as in professionals. We're grouping those into a whole year, a full year course where students will learn by doing. They'll learn by taking those concepts that they've learned in their science and math course, take those concepts they've learned inside the course and integrating them to solve projects, a sequence of 5 projects that grow in scope in depth and in breadth throughout the course. They do this in a team paradigm, team mechanism, and I'll be talking about that in some depth. And I'll give you actually a couple interesting insights into some of the projects students are working on right now in our programs. And finally, we recognize that to make a complete engineer and to make a complete individual as they progress with a broad background, electives are essential. So students need to get those sciences and maths essential. You need to know how to apply them to solve problems in our first of a kind course, but also you need to expand your breadth beyond engineering courses. And so complementary studies electives are integrated immediately in first year in order to complement your engineering education. So who better to talk about our programs than one of our students? And so Faiza here is currently a level 4 electrical engineering student. And reflecting on her first year experiences, her comments were that the general first year option is so helpful when deciding on what stream you want to apply for. It can be difficult to know right out of high school exactly what you want, and the ability to explore a little bit of everything is a unique one that lets you get an idea of what's out there. And indeed, this is a common comment from most of our first year students. And the statistic on the top right of the slide is telling. Students, 60% of our students change their mind when progressing through first year. So when asked upon entry what discipline they want to go to, they change, 60% of those students actually change where they think they're going to end up going through first year. And this is really an example of what our first year program does. It gives students the ability to make an informed decision. Over a whole year, they'll get a sampling of all of our engineering programs, and then they'll be able to make an informed decision after consulting with students in those programs and faculties in those programs to find the program that fits for them. And that's really essential, right? So that they find what fits for them and what really interests them in the long term. So let's dig down a little bit and talk a little bit about what we mean about project-based learning, and then we'll talk a little bit about some examples from our current first-year curriculum and what we've innovated in that space. So I can say without any trepidation that we, as a faculty, McMaster Engineering has transformed engineering education. We are the first to integrate project-based and experiential learning to the degree we have and the size of program we have throughout all levels of our program. And so we believe that engineering is best learned by doing as well as by studying. So you study, you can learn the best and acquire skills by actually applying them. So let me show you a little bit, a quick overview of our first year course that we're very proud of, our Engineering 1P13, which is entitled Integrated Cornerstone Design Projects in Engineering. Now, this is a course that spans 8 months. It runs all the way from September to the end of second term. And what the nature of the course is very different than a conventional or a conventional engineering education. In fact, our modern approach starts by having an introduction of concepts. So there are some lectures. We do have 3 hours of lecture, 3 one-hour classes per week to give students that knowledge, to have a qualified, a leading faculty member present these technical topics and engineering design in a lecture. The next step, immediately after you've seen a lecture, the next step is really to develop skills. And students do that by doing labs. And so we have labs that are mentored by a large team that allows students to take those concepts that they've heard about and seen in a lecture and actually apply them by themselves, right? So go in, but they're not doing it alone, they're mentored. And finally, having the concepts and having mentored skills is good, but you want to be able to put those skills together to solve a real problem. That's what we want, that's the next step. Apply these skills that you've now learned to solve a multidisciplinary project, a project in a team. So students will have design studios that they're gonna work on 2 hours per week with a group to solve these projects, these set of 5 interconnected projects growing in scope throughout the first year. And I'll show you some examples of each of them right now. So our Project Zero, our very first project, is one in which students learn about coding and learn about sensors and integrating data from sensors and coding in order to control a robot to follow a line on the ground. And so these robots on the right-hand side, you'll see a real robot inside of a boundary, and students will have to program a computing platform that they receive and to control this robot in real life. Now, again, students work on this in real life. Students, again, who can learn coding skills and practice them in this environment. Of course, they have a certain number of hours per week to practice this in real life, but on the left side, you'll see a virtual model that we also provide. So yes, it's important to be able to practice in real life, but engineers work with a whole host of virtual tools. On the left side, you'll see a virtualized model. It's a model that runs on your laptop, and you'll take the same computing Raspberry Pi platform, connect it to your laptop, and you'll be able to control a virtual version of that robot. In this case, that robot is in a photorealistic render. It actually looks, for those of you that are interested in gaming, it may look familiar, because in fact, the engine that drives this is a popular gaming engine that drives many of the video games that are incredibly popular these days. So again, students will have the opportunity to work in groups, to build solutions, try them out in a virtualized platform as many times as they want. They can crash that robot in the wall, they can do whatever they want there. Learn, take those concepts, apply them, build solutions, and iterate on them. Once they have a solution that they think is good and can work, they can take their time and do it on a real cutting edge robot in the lab, right? And so this happens with all of the projects in this first year course. You'll be able to have these cutting edge tools that are customized, that allow students to learn, give them the freedom to explore those concepts, to learn experientially, not just to listen and see engineering, but actually try it out and try different solutions out in a virtual space as many times as they need and want, in group setting with support from our instructors, and then do it in real life and see their successes there. Another example, these projects grow in scope, and you'll see very quickly by project number 3, students will build a recycling sorting system, so material identification, sorting, and a recycling system. So on the left-hand side, you'll see the virtualized model that the students have. They'll again program their computing platform. They'll have to program a turntable in order to rotate different materials. They'll have to select sensors from a collection of sensors, interface them to the computing platform to identify material, to characterize the materials, to weigh the materials. Then they'll have to program the robotic arm to go pick up the materials and place them on the terrestrial drone, robot on the right side there. That robot will then have a 3D printed mechanical structure that the students will have to design that will transport and then deposit the items in the appropriate bin based on the classification. Again, students can practice all of this in a virtual environment beforehand, at home, in groups, whenever they have time to program and figure out this much more clearly. Is a more complicated example. But then on the right side, you'll see an example of our robotic arm with one of our instructors there and a TA. And you can actually practice that and try it out once you've debugged it in virtual space. You can go try it out in a real life facility and see how your design works. Again, learning by doing, learning in cutting edge tools, virtual tools, learning using cutting edge tools in person. Exactly what engineers do in real life. This 1P13 experience may sound daunting. Yes, students learn a lot. They learn things quickly. They learn things by doing, but they are mentored. So you'll notice that on the left side, they do have 3 hours of lecture per week to get the concepts, but immediately they jump into a sequence of labs and design studios where they integrate these concepts and projects. The point I want to focus on here is that dedicated support bubble that you see there. And the team that's around to support students to be successful in these programs is a team of 6 faculty members that are dedicated to our first year program, 5 staff members, again, to support in the organization and coordination of this course, 10 instructional assistants, and 100 teaching assistants. So students are not left to their own devices to say, here, figure it out. They are mentored, they are guided. And again, this is one of the key reasons why we have such great success in our first year and students transitioning from first year to second year, because we care and we invest a lot of time and effort to ensure that all students that come here are supported through their educational journey. So what happens after I finish first year? Well, after first year, there are a number of engineering disciplines you can pick. They're listed here. There's some classical engineering disciplines and some more modern engineering disciplines. It's a comprehensive engineering program. We have covered essentially all modern and classical areas of engineering that are industrial and practical use these days. Students can consider 4-year programs. There are 5-year programs such as chemical engineering and bioengineering, as well as we have 2 options, and I'll talk about them in a second, that can extend your engineering degree to 5 years, but then they give you the opportunity to specialize in some areas that are non-technical in nature, but that complement your engineering education and give you the ability to tailor where you want to take your engineering degree and prepare you for a career that fits for you. In the top right, you'll see the free choices in the mid-90s. So this choice happens at the end of first year. Students will make a choice of program at the end of first year based on their marks in our common first year. There are a number of students that are in their mid-90s in entry average that will be offered in their offer letter this thing called free choice. That means that they will be offered the ability to choose any program, maybe guaranteed that program, again, upon entry, if their average is then in that range of the mid-90s, and it will vary from year to year depending on our entrance. So those 5-year programs, we have 2 options. We have the engineering and society option and the engineering and management option. Engineering society is the first of its kind in Canada, and students here are able to integrate an accredited, rigorous engineering program, same as our 4-year, same as the engineering programs we've been talking about now, but they can integrate it over a 5th year, so spread out over their 5 years now, complementary studies area that fits with their interests and their passions, right? This builds someone that is an engineer, but that has the tools to be a creative and inquisitive, well-rounded engineer. So we have a number of students that take that to either deepen some topics in mathematics or economics or in the humanities. And that's an ability to expand and look at a more well-rounded engineer in that case. We also have the engineering and management program. This is a prestigious, long-standing program, again, a 5-year program, which integrates aspects from our DeGroote School of Business into our engineering programs. Again, as graduates of this will get an engineering degree, a Bachelor of Engineering, which is accredited and licensed in Canada, but they'll also have a Bachelor of Engineering in Management. That's the degree name. And it will give students the ability to get deeper experience in project management, business skills, leadership skills that are essential for entrepreneurial and corporate future. So again, students can choose in their first year whether they want to take either of these options. And there are limited spots, but and I'll talk about the number in a second. But these again allow students the choice to emphasize or to focus on particular aspects of study to again extend over 5 years in this case, and then focus on a particular area of study. So what happens? What are the sizes? How many spots do you have? Well, our departments are of different sizes. Some are large, some have more second-year undergraduate spots, and some are smaller. So you see the list there in order from largest to smallest electrical and mechanical have the larger number of seats available, and engineering, physics, and materials have smaller number of seats. Again, entry into those second-year programs is competitive and based on your average in first year. The management option has about 150 spots, and that can be applied to any of those programs in the departments, and society is limited to about 60 spots for our entrance. All right, so we've talked a lot about first year. I'm just going to touch upon what happens after first year in terms of experiential learning and project-based learning. In second and third year, we have new courses. The first launch is this year, a course called 2PX3, which is an integrated engineering design project. Students from whatever stream they enter into, whether it be chemical or civil or electrical or mechanical or any of these other 10+ programs we have, will merge together in second year in a common course called 2PX3. It'll be a multidisciplinary design course where they're going to solve an engineering problem, but they're going to use communication skills. So they're going to acquire engineering communication skills, both written and verbal, and use those in a multidisciplinary team to solve a real problem. In third year, students will take aspects of engineering economics, learn about costing of projects, costing of elements, which is indeed essential for any practicing engineer, and do that again, not just with students from their own stream, but students across all of the engineering programs in a multidisciplinary team to solve problems as well. And finally, all of our programs culminate in a capstone course where students can take all of the technical knowledge, all of the ideas and skills they've gained throughout their previous years and apply them to solve a real world problem. All right, so how do you get in? Admissions and applications. So entrance is based on a number of factors. It's based on 2 things, both on your grades, the average coming in, as well as your performance on a supplementary application. So the courses are a 4U English, a calculus, chemistry, and physics. We'll calculate your average based on those core courses, as well as 2 other grade 12 URM courses. The cutoff average is 87% minimum, though entrance is typically higher. And the admission is not solely by average. We believe that you are not characterized by single average. The quality of an applicant is judged by many factors, and that is why we have a supplementary application for all of our engineering programs, but in particular for our Bachelor of Engineering programs. Now, what's in that supplementary application? This supplementary application is a mandatory component, and it really gives us the opportunity to learn who you are beyond that average, right? Beyond that average, what experiences do you have? What have you achieved? What is your thinking on certain areas, and how are you able to articulate them? And again, it's an online questionnaire which has both live video answers that you need to do, as well as a text portion where you have a written answer that you have to do. And the problems will be solved. The questions will be solved a lot about learning about you, learning about your ability to communicate both in written and verbal format. You'll notice that in a project-based format that we have, those skills are very important, as well as skills such as problem solving, collaboration, etc. These are important skills that we need for our students, and that's where the supplementary application comes in. It's not an onerous application in terms of length. It takes about 20 minutes in length to complete. Now, what is the format of it? There are 3 video questions that you'll be asked. You'll get a minute to collect your thoughts and prepare, and you'll have 2 minutes to answer the question. There's also one written response. Once you're given the question, you get 10 minutes to answer it. There are a number of sample questions, and there are no right answers to these questions, but really we're there again to understand who you are and to see how you're answering the question. So questions like, what does being resourceful mean to you, and why is it important? Tell us about a time management strategy you used. Why does it work? So relate something from your past. Can you articulate accurately how it works, why it works? Another example is, what circumstances make it okay to take a risk versus playing it safe? Please explain your opinion in detail. So we're looking for students that are reflective and are able to understand these processes. So again, the supplementary application is a key element of our admissions process here, and admissions is based both on the grades and on your performance on the supplementary application. All right, so scholarship applications. These scholarship applications can be completed on AwardSpring, and they're not used for admission, but they are used to recognize students that have achieved great things in their curricular life, in their academic life in high school, as well as in their life outside of school. And the steps there are a number of steps. The steps are, first, tell us about your awards, your extracurricular activities, what you've done, your accomplishments outside of school and inside of school. We think those are important and should be lauded. Then we're going to ask you about 3 questions, and questions will be on topics of collaboration and inclusivity, questions about impact. Can you tell us about your impact, an impactful event that you've done? And then a big idea. Reflect on a big idea that you may have to solve some big problems, because in the end of the day, engineers, the definition of engineer is someone who solves problems using technology. And so big ideas are a key component to that. And so our aim here is to recognize and reward students who have great academic achievement and have demonstrated leadership in their community. And that includes both our academic awards as well as our Engineering Research Experience Award. And I'll touch upon that in a minute, a bit later in this presentation. So why McMaster Engineering? Well, you know, we've talked a lot about the particulars about how to get in, the mechanics of getting in, and supplementary applications and averages, and a little bit about what the first year content and this new way of learning that we have pioneered here at McMaster. But the real fundamental essence of why McMaster Engineering is a unique and world-leading program is because we recognize that education is centered in the student. And our job is to give you the space to define those experiences, in addition to that core rigorous technical education you'll get here. Define those experiences you need to succeed as an engineer, and we will help you get there. And we call this approach design plus a degree plus experience. You have that degree, that all of our programs are rigorous, world-renowned engineering programs, but the differentiator really is the experiences and the mentorship we can give you to complement those skills and to integrate them into the wider design ability. So some examples are a degree plus social impact, right? You could take that engineering degree and integrate it with a society option over 5th year in a particular area of social impact that you want to investigate. Degree plus innovation, entrepreneurship, through our management program, through our innovation minor. There are many different avenues in order to explore innovation and entrepreneurship within our engineering programs, combining engineering with this topic. Degree plus clubs. So I'll talk about clubs and teams in a minute. There are huge amounts of benefits to doing clubs and teams outside of your engineering curriculum, both technical experiences where you can actually apply your engineering skills to build a Mars rover or a rocket, or non-technical elements, and I'll talk about them. And at McMaster Engineering, we'll actually reward you with course credit for technical and non-technical activity in these clubs and teams. Degree plus research. I'm gonna talk also about the fact that McMaster Engineering has the largest undergraduate engineering research program in Canada. We believe research is a great place to learn engineering. And we have world-renowned researchers. Being a research-intensive university, or the most research-intensive university in Canada, we have among the best researchers, and they integrate undergraduate students in their studies. Degree plus balanced life. After all, well-rounded individuals are important. You'll notice that I've mentioned the ability for complementary studies electives immediately. Having that technical skills, the science, the math, the engineering design, and engineering science components integrated with knowledge from outside of engineering. That's what makes a great engineer. That's what makes a great problem solver that understands all the complexities of problems in this world. And finally, degree plus co-op. We believe co-op is a great and essential way to learn engineering, not just in a classroom, not just in the auspices of a university, but in the field, in practice, in an industrial setting. And there are plenty of places that offer co-op, but the differentiator for McMaster is that we believe there is not a one-size-fits-all co-op option for students. We do not believe that 4 months on, 4 months off is the best way to do it for everyone. It fits for some and not for others. And so again, with this ethos of degree plus experience, we're here to support your aims. We're here to support your decisions on what is the best way for you to experience co-op. So every student has access to this co-op program, and you're going to decide, you can decide how you want to access that co-op program, and we'll help you get there. So McMaster Engineering has the second largest co-op program in Ontario and growing. So co-op is integral to our engineering educational experience here at McMaster. It's growing. It's not a fit for all our students, but it is a fit for a majority of our students. Again, not in a homogeneous way, in the way that fits them and that they can integrate into their studies. So what do I mean by that? So when can I go on co-op? In level 1 and 2, we limit students to a 4-month co-op stints. Again, as they're maturing, as they're developing their engineering skills, that's a perfect time to take those shorter stints to get those kind of shorter experiences. After that period, at level 3 and up, they can take 4, 8, 12, or 16-month co-op terms. Now, in order to achieve a co-op designation on your degree, you need to have at least 12 months co-op over your time in your degree and your studies. However, some students can go far beyond that and get the co-op designation. Some will choose to do less and not have the co-op designation, but nonetheless leave with that valuable experiential learning. So here are some examples on how to do it. These are just some examples. You could look at a 4-month work term in between each of your academic years and summer stints. You could do a mix and match. You could take your first term off and then do a 4-month and then an 8-month co-op. You could look at a 12-month co-op at the end as an internship, or you could do what we call the works. You could have 4-month and 12-month internships, again, to maximize your ability to participate in blending industrial work, in practice, work, and learning in an academic setting together. Again, these are choices that reside with the student, and our job is to support the student in doing that. Having said that, students are engaged in the co-op program from the minute they enter it. We have a team that's dedicated to supporting our students, both with online co-op courses that they'll take in first year to prepare them. Again, applying for jobs, making a good resume, making good LinkedIn profile, understanding how to do an interview. These are all essential skills that are not taught in a course, you know, in engineering, but they are taught in our co-op program. And they're some of the essential skills that a practicing engineer will tell you that you need to be successful. We have over 350 events in the year, and this is to link our students with employers. I'm gonna talk about some of our employers in a minute. We have a team that will advise you. Career advising is super important. You have mentors there that will help you through this process, and we don't leave you on your work term. You're still our students, and so you also have support during your work term from our co-op group. So companies that our students go out to are span the gamut. Canadian companies, US companies, international companies, big companies, multinationals, and small startups. Companies that are engaged in research and companies that are manufacturing items that you can go buy on the shelves today. So there are a huge number of companies. Just a snippet is shown here. The list is always growing. And again, they're in all different disciplines. And so students in all of our multitude of programs will always find a fit. Some may choose to go for large companies in one work term and then get an experience in entrepreneurial or startup in another one. Again, that diversity of experience, that fit, is up to you to define and for us to support in you gaining it. Some stats, again, that here, about 80% of our international students choose co-op. The co-op placements are not limited to Hamilton or Ontario. They are worldwide. They are world-leading industries. I've shown you a couple snapshots of them, but again, our students are employed in leading industries, getting real engineering skills in the foremost firms in the world. They do this all whilst getting paid. The average salary is about $50,000 annual salary while they're working. And we have over 6,000 positions posted per year, which means there are a huge number of opportunities in a variety of industries. So this slide is one of my favorite. All work plus all play equals opportunity. So we at McMaster recognize that learning doesn't stop when you leave a classroom. You know, you can learn in a huge number of activities inside, outside of the classroom, in our clubs and teams. So you see pictures here, you see on the left, you see an example of our engineering musical. Our students that are participating in that yearly event, which is truly inspiring. You'll see the next one over is our Mini Baja team that produced this off-road racer. You'll see elements of our IEEE student branch building circuits and participating in hackathons and circuit design competitions. You see our Mars rover and our rocketry club as well. So again, we at McMaster, it's not just lip service. We're not just saying we think you can learn in a club and team. We will give you a technical credit for technical activity in these clubs and teams. So if you're building the drivetrain on the Baja Racer or an electronic subsystem on the Mars rover, these projects are mentored by faculty members, and you will have those assessed and get technical credit on this course for activity that you work on your clubs or teams. If you're a leader in managing the musical or in leading the electronics club or doing a fundraising or an outreach activity for the rocketry club, this non-technical activity is important, and under the mentorship of a faculty advisor, you'll have an opportunity to reflect on that and get a non-technical complementary studies elective based on your leadership activities in these clubs and teams. So at MAC, more than just saying we believe clubs and teams are important, more than just supporting students in doing it, we will give you credit because we recognize and believe the learning that happens in those clubs and teams is just as important as the things you do on an exam or in a classroom. This is all about engineering and solving real problems. And we believe our students can do that in the class and outside of the class. And finally, I've mentioned it a couple of times, and we're incredibly proud of the fact that McMaster University is the most research-intensive university in Canada, and we have the largest undergraduate engineering research program in the country. Over 500 students per year enter research programs. We have world-leading researchers teaching our students in their classrooms, and those, you know, they're not limited to that. These researchers do not just teach and then go back to the labs and do research. No, they take those students and integrate them into their labs. We believe that learning by doing research is an exciting and an important way to learn engineering from the get-go. And so far from just having researchers separated from undergraduates, we integrate them. And I can tell you as a faculty member, I've had a huge number of students through my lab. They've written papers, they've worked on a large number of research projects with me over the years. And so this is a common thread through all of our faculty members here at McMaster. We also recognize that human beings our students are human beings. And so a balanced life is important. We call ourselves a Fireball family, and we mean it. We are a supportive community that fosters collaboration and wants all students to succeed. So we're here to support one another, and competition is not our focus. Yes, we have rigorous world-class technical education, but we don't do that at the expense of not supporting one another. Our aim is to have students supported and succeed in our programs, and that's done in a huge host of ways through our advising team, through our non-technical, through our events, to ensure that students are recognized for the work that they do and that they're supported and having a complete and balanced lifestyle. We believe that's certainly important for all of our students. And that commitment to support doesn't just start when you're here at MAC. It happens before students even arrive on campus for the first day of class. So we have a program that we entitled Ember. Again, fireball is our symbol, and Ember is the start of this spark that ignites into this fireball, the student that's about to enter. So if you choose to accept an offer at McMaster Engineering, we will support you even before you arrive. We recognize that you are our student. We want to make sure that you have the maximum possibility of success. We have 100% free but optional 3-week prep program in the summer before you arrive on campus in September. Now, there are multiple components in this. One of the components certainly reviews the math, physics, chemistry, and computing topics that you may have considered in your high school. So those fundamental concepts, not new academic material, but we'll review them. This gives you a number of things. Well, it'll give you an ability to see where you're strong, where you need to improve before you enter programs. But secondly, and most important, we're going to provide this review in the way that a university lecture is done, okay, with the same cadence, temper, and expectations. So when you enter our first year program, you start engineering at university, you're already aware, you have some comfort level on the way the instruction is done. Integrated with this academic prep or this academic review is also the ability to connect with our Fireball family, with our students, with our faculty, with our staff, with our clubs and teams, with our advisors. They're going to come every day and give you the ability to interact with them, to meet them, to see all the opportunities you have, to understand all the different engineering disciplines. This starts right away. So you can kind of see what your options are, see where you fit, see what experiences you may want to collect during your time at McMaster in order to make you reach that trajectory, that place where you want to be in your career. There's going to be a number of interactive workshops to allow you to connect with your peers. Again, we want to make sure students are connected to one another in first year, that peer group being essential, especially with project-based learning. So we're going to connect you with your peers, connect you with all of the great supports and facilities we have here at the university, and make sure that you're comfortable entering into our first year. And this is not done just asynchronously, like here, watch this video. This is done live with individuals that are dedicated to you. Again, this is an example of the commitment of McMaster Engineering to our students. Again, those that even before they arrive for their first day, we want to ensure that they're successful and feel comfortable and prepared to succeed in our programs and beyond. So there is no one way through our programs. You can see that our job is to put students at the center and allow them to define their experiences, define where they want to go. But here's a sample trajectory of that a student may take. In level 1, again, they start the program, they complete the Ember program, they take the co-op course, so they're prepared for their co-op program. They may join their first club and then do their first 4-month work term, perhaps a research stint in a lab. In level 2, they take on a more senior leadership role in a club. Perhaps they're managing a certain subsystem. And then they take a second work term, perhaps in an industry, a local industry. In level 3, our students have the opportunity to be TAs, teaching assistants for first year courses. Again, best way to learn is to teach. Again, this collaborative environment starts. We support one another in our learning aims. Upper year students aiding students in their initial stages of their studies. Again, this fits immediately into the ethos of our McMaster Engineering community. And then the student may choose to go on a third co-op work term for a longer stint, perhaps an international co-op at a leading firm in the United States or in Europe or beyond. And finally, level 4, all of our level 4 programs, all of our programs culminate in a capstone, the ability to solve an open-ended problem using the engineering skills you've gained. Again, the best way to learn engineering is by practicing it. That reaches its culmination in 4th year when you've learned that level of skills through your program. You maybe then have increased to a senior leadership position in a club, perhaps even the president of a club. And of course, we're all here to celebrate your graduation as you go on and realize your big dreams in industry or in research or wherever the world may take you. Again, the best way to understand the opportunities that are available for our students is to talk to or see examples of our students or of our graduates. And so here are a couple examples, just a few examples of some recent graduates from McMaster Engineering programs that really exemplify this notion of degree plus experience. So I wanted to introduce you here to Lacey. Lacey is a graduate of our Mechanical Engineering and Society program. She was also involved in our Baja racing team as the president of team, that racer that you saw, and she was actively engaged in biomechanical research throughout her studies as again, a co-curricular activity. Lacey graduated recently, and she's now completing her Master of Science in Cellular Biology and Anatomical Sciences. Again, getting that really deep graduate experience in science to complement her engineering design expertise. Again, these experiences together were chosen by her to complement the design, to build the set of expertise in order to achieve the career and the objectives that she wants. So these experiences together, recognizing that it's not just engineering, that these other topics are just as important, these together form a complete engineer. I also wanted to introduce you to Thomason. Thomas is a materials engineer. He's a graduate of our program. He's been excited by steel research and done it for some time. But again, we recognize that, again, degree plus a balanced life is important. And so again, Thomason is a bass guitarist. And so these skills together form not just a great engineer, and we think those non-technical skills are just as important as the technical ones in formulating a complete individual that is able to solve problems using technology. That is the essence of an engineer. After graduating recently, Thomas is now working as a junior process metallurgist. Again, taking those experiences, solving real-world problems in metallurgy. So the message I want to leave you with tonight is that we at McMaster Engineering are here to allow you to define your experience. We'll give you the information, we'll give you the guidance, we'll give you the support in order to see the options and define those experiences which are essential to you, which fit with you, and then we'll support you to get there. You're not going to be doing this alone. You'll have a large team of people to support you, from your faculty, from our staff, from our co-op team, from our advising team, from our level 1 team. There's a huge team of staff that are dedicated to your support. Their job is to support you and to make sure that you feel comfortable and supported throughout your studies here at McMaster Engineering. This is just one opportunity for you to hear from me, the Associate Dean, on our undergraduate programs. I'm very happy to have a chance to talk to you tonight, but there is another opportunity coming up very soon. It's called the Ultimate MacEng Hangout. It's coming on Saturday, November 13th. It is a virtual program as well. And the unique feature here is that you'll have a chance to interact in some fun and creative activities with our students. And again, I encourage you all to attend that if you have interest in any of our programs, be that in engineering or in biomedical engineering or in BTech, a Bachelor of Technology, or in computer science. Please go and check out the MacEng Hangout on the weekend. You'll have a chance to hear firsthand from our students, their experiences, how they're experiencing MacEng, the different clubs and teams, different aspects they've taken, and to get an idea firsthand from a real student what their experiences are here at McMaster Engineering. In fact, our best ambassadors are our students, and we invite you to certainly interface and talk to them this weekend. Finally, I see we have a couple minutes left. I'll certainly be taking some questions now. If you've been asking questions in the Q&A box in the bottom, please continue to do so. I'll answer a limited number. However, our team will stay on and answer all the questions for you. If we don't get to your questions or you have questions after the fact, feel free to email us at thinkeng@mcmaster.ca. This is a convenient way to connect with us, or you can certainly use the QR code that's indicated on the slide here to connect with us and ask any questions that you may have. All right, so I'm going to go look at the Q&A section. I'm going to go look for some questions to see. Oh, I see that indeed we've posted the registration information for the Hangout as well. It's coming, so that's possible for you. So I have a question here about free choice. So free choice is offered to a number of students. It will be indicated in your offer. So if you apply to McMaster, any of our to our level 1 programs in engineering, if your average is in the mid-90s or above, again, it depends on our algorithm. It changes from year to year, but there will be a cutoff, and students that are above this average will be offered free choice. This means essentially that throughout their first year, they're guaranteed a selection in their selection progression from level 1 to level 2 as they progress through. Okay. So there's a question on the female to male ratio. What is it like? So It will depend on program to program, but overall for engineering, it's in the mid-20s%. So 20% of our class is roughly female. It will depend. Some programs have 60% women or the individuals identifying as women to men, and some have less. And so it will vary from program to program. But again, engineering as a profession is committed to increasing the representation by underrepresented groups in engineering, and that certainly is important to the entire profession going forward. So thank you for that question. So there's a question I think is a really good one. Is this webinar being recorded? The answer is yes, as are the ones for the other programs. So please do feel free to watch them, rewatch them, and ask questions at a later time if you feel that's important. There's a question here about, say I decide to go on an extended co-op for 12 months after level 3 or 4. So students certainly have the option to extend programs over longer periods of time. The co-op term, however, your work term cannot be your last term. So it's got to be sandwiched. There's got to be an academic term after. You have to return after a work term to do an academic term. But yeah, there are a huge number of options for students to do 4-month or 12-month or 60-month work terms to get a larger amount of work experience in coordination with their engineering degrees. Again, I didn't have a chance to go through all those customizations, but we do have teams of advisors that are available, as well as our co-op advisors and academic advisors that work together with students that want to meet those objectives, again, to make sure that we can enable you and support you to meet them. So thank you for that. Thank you for that question. Okay. So there's a question here, is the selection process based on grade 11 or grade 12 marks? So we're only going to look at your grade 12 marks. The grade 11 marks are not going to be part of this admissions process. Neither is the ranking that you put us in the OIX system. Again, we're looking just at your average in those courses that I mentioned, the English, the chemistry, the calculus, physics, and plus those other two grade 12 courses, plus the supplementary application. Again, I don't want to emphasize that this is not just a cutoff based on grades. We do look at that supplementary application. It forms an essential component of your entrance into our engineering programs. There's a question here about computing and about whether computing is required as a course in engineering. So I did mention that in Ember, there is a computing component, the programming or computing as we call it here. Again, it's not required for entry. We will teach you in engineering everything you need to know. If you haven't taken a programming course, that's fine. We will teach these components in engineering. Of course, it is an asset to have computing background, but it's not required. In Ember, we do have a computing module, which reviews some basic concepts and constructs. So what we're doing is we want to make sure you have the right software installed, the right package installed, you understand the basic frameworks. This is more general knowledge, not essential, not necessary for academic programs, but really does help students feel a little bit more comfortable as they enter our programs. Okay. So there's a question here about applying to McMaster, about a minimum average is 87%. And so that is a minimum average for the application to be accepted. But again, as I said, the average only forms one component. Typical averages will be higher than that for students that are admitted. But again, average forms only one component of our admissions process, and supplementary application is important. There is a question about timing of offers of admission. So the submission, if I could just review, the submission of applications through UAC is the 13th, is somewhere in the middle of January. That's when the application will come in. The end of January is the deadline for your supplementary, somewhere around January 28th. Scholarship applications are due by February 18th. And then document submission by the 1st of April, and then offers to be accepted by the 1st of June. Okay, and so offers do typically occur early in March, but a majority of offers will show up in May, okay, with acceptance due by June. So I hope that answers the question. So they'll happen over the year. Again, given that our process is rigorous and we're looking not just at your grades, but at a supplementary application, we will review all of these things in making our final decisions. Okay, let me just. There's a question about co-op and whether you have to decide on co-op right away or if you can change your mind. And you can apply for co-op or non-co-op stream. It doesn't really matter, and you can change at any point prior to your final year in school. Again, our aim here is to be flexible as we can possibly be, and our aim here is to support students as they go through their programs. I'm just waiting for another question to pop up. Okay, there's another co-op question about whether the co-op program is competitive to get into. And so the answer is no. We don't. We allow that opportunity for all our engineering students. Again, once you're in engineering, once you get in, we believe that co-op is an opportunity for all our students that they should avail themselves of if they like, and they'd like to be able to avail themselves of that in a format that fits best with their educational aims and their career aims. And so, no, this is not that is not a competitive position. Okay, I see another question about co-op and whether international employment is possible. Indeed, you know, the question asks about Silicon Valley in particular. So we do have students in Silicon Valley and in leading firms there, both in research and development as well as in industrial engineering there. We have students in Canada, throughout Canada. We have students in Asia and in Europe, all around the world. So in 30+ countries, we have students that are engaged in co-op. Again, as I said, we have the second largest co-op program in Ontario, and we're growing. And we believe this is a fantastic way to learn engineering by, in fact, practicing it and doing it. Okay, I think we have time for one more question. Okay, there's a question here about the supplemental application. So I've mentioned a couple times how important the supplementary application is. And then the question is, you know, can I practice, right? So yes, indeed, it's not again, as I said, it's an important application process. It is not looking to catch anyone. We want to make sure students get ample opportunity to practice and to try out questions. So we'll give you an unlimited number of practice sessions, some practice problems you can try, recording videos and sample written ones. That's so that you feel comfortable with the interface, you feel comfortable with the mode of replying. Again, however, once you begin your formal interview, your formal test procedure, then there's only one opportunity to answer. But before that time, we want to make sure you get a lot of chances to try it out so you're comfortable and ready to answer the questions in the best way. All right. So I see that it's 8 o'clock. Again, our team is going to be ready to answer your questions. If your question was not answered in today's webinar, that's fine. We look forward to answering your questions both offline at thinkeng@mcmaster.ca or connecting with us at the QR code listed on the slide. Once again, I would like to thank you all very much for attending tonight. Attending this webinar tonight or today or wherever the time is in the location you're in. We are passionate about McMaster Engineering. As I said, our Fireball family is a collection of students, staff, and faculty members. We're all devoted to ensuring that our undergraduate students have the best world-class undergraduate engineering education in the world. And we believe we have the most modern educational methods as well as the experiences that are here to train engineers of the future. Thank you for joining us. Again, we welcome any questions into the future and look forward to answering your questions. Thank you all again, and greetings from McMaster Engineering.